Good morning, everybody. So 2022 paper we are discussing today. This is our last day that I'm guiding you guys with academic. But next week, I'm going to do another little speech. And it's not online. I'm going to do this recording and I'll post to both Ratnapura and Colombo classes. A couple of students will stop the class in the middle of these doing papers, whatever the reason. I guess they couldn't catch up with everything. Like from the beginning, I was just saying like you have to do two different things together. One thing is theory, and the second thing is questions. But once I'm done theory, they get this little misleading them, like they are already okay with chemistry, so they can go with other two subjects. I know you guys are still struggling with other two subjects, some of you, but still you have enough time. Never ever give up. You can do this. Okay, all the Ratnapura students, Afra, Amaya, Chanupa, Dimantha, Dilu, Kaumadi, Kayatri, Manori, Saranya, Nuha, Pahan in both, and Piumi, Tisharini, Zara, Enuri, Yashika from Colombo. Some students are there, and also all these Colombo students, if I remind all the names, Dilunika, Liana, Ramudi, Senara, Tara, Tarinduni, Vihas, Diana, Netmi, Pahan, Tasindu, and Rasindu in Sinhala medium I have added here anyway. Okay, so all you guys, like we went through all this path, like we did everything possible. Some started to fill their glass from the beginning. Even you started to fill your glass from the beginning. Or even if you started to fill your glass at the path, somehow, if you manage to fill the glass fully, that is what we needed. And now we are there. So please, everybody, I want you guys to listen this last recording and 2022. And I'm guiding again you, I'm instructing again, you do this 2019 onwards papers like 5 times until you feel like all these easier stuff, you can just keep, then whatever the challenging stuff, go through them until you feel there are no more challenges within this paper. So then your 2023 paper, I don't expect it's going to be really, really hard one. It would have challenges comparing to 2022 because 22 paper is like so much easier. That's why there were a lot of 9As. Sorry, a lot of 9As in this. They have a lot of these 50 MCQs, correct? 50 out of 50 MCQs. There were a lot. And I wouldn't expect that from you guys. But still, let's say even district first is, if the district first is Deepna, still she get that. Maybe her ISA score is getting lower, but still she would be there because regardless, the paper is easier or paper is harder. Let's say from Ratnapura, this time they were selected like 115 students. So first top 115 students are going. From Colombo, let's say 350 selected. So the first top 350 students are going. So it doesn't matter whether paper is easier or harder. You just need to carry on. And please carry on. Okay, I'm going to start the last lecture. Since we are coming all these online and I don't want to waste your time, and so that we are not doing these parties and all this everything. Actually, I feel like we don't have to waste time because all these classes are doing parties and songs and everything. You can have this pretty beautiful life what these students are having in front of that. You can see their faces are really, really like so much happier. And you can go there, you can feel everything once you're done with this exam, okay? All right, so we are moving on to our last paper, that is 2022 paper. Christmas comes in. 3 years consecutively, I went to this Shangri-La Hambantota. They have this gala dinner and everything. So one of these pictures I found, and it doesn't matter my short because, you know, like now I'm very, very friendly with you guys and we are like one single family. I guess boys wouldn't care with my short. So you can have this life right after this. Just be happy that we are there because we're going to win this. We're going to win this game. All right. Okay. So let's write these answers. I don't know where is this Zara, Afra. I just sent this Colombo ID to that. Maybe they were using a wrong ID or something. Anyway. Question number 1, answer 2. 2, answer 4. 3, answer 1. 4, answer 5. 5, answer 3. 6, answer 5. 7, answer 4. 8, answer 1. 9, answer 3. 10, answer 3. 11, answer 5. 12, answer 4. 13, answer 3. 14, answer 3. 15, answer 5. 16, answer 3. 17, answer 2. 18, answer 5. 19, answer 3. 20, answer 2. 21, answer 2. 22, answer 1. 23, answer 5. 24, answer 5. 25, answer 3. 26, answer 3. 27, answer 4. 28, answer 4. 29, answer 5. 30, answer 3. 31, answer 1. 32, answer 4. 33, answer 5. 34, answer 5. 35, answer 1. Oh, Zara is coming. 36, answer 1. 37, answer 2. 38, answer 4. 39, answer 5. 40, answer 2. 41, answer 2. 42, answer 1. 43, answer 3. 44, answer 4. 45, answer 2. 46, answer 1. 47, answer 5. 48, answer 2. 49, answer 5. 50, answer 4. Zara, darling, did I do a mistake like sending you these different IDs? Because in this tab, it is showing 2 different IDs. That's why I have sent this second. All right. Anyway, Zara, it's okay. Even if you're not checking here, that we're going to go with this paper. All right, let's start. From Colombo, once I come in here, sometimes my maids are arranging everything like so differently. Then I have to struggle a little just to catch everything back to normal. Okay, we can start. I'll give a little time to Zara. Belong to visible region. To come to visible region, I would say 2022 paper is unbelievably easy and a very unfair paper. They were just checking this a basic knowledge of students. I guess that's because 22 students are the most affected by COVID. Right after they started their advanced level, COVID, economic crisis, fuel crisis, everything were there. So don't expect this easier paper to you. This paper is extremely easy. Okay, so n equals to 2. Balmer, emission they're asking. Number 3 is absorption. Question number 1, answer 2. Incorrect statement is asking for second one. You guys have the answer, so I'm gonna go with this explanation. Pauli exclusion principle excluded the possibility of the presence of third electron in an orbital. That is true. No orbital can accommodate more than 2 electrons. So it can keep only 2 electrons. So it is excluding the third electron. And the second one is twins of 2 electrons must be antiparallel. So there is no way of having the third electron. In the potassium atom, number of electrons having quantum number, main principal quantum number 3 and magnetic quantum number 0. Potassium, see, now this is the way they are asking this question. They keep asking this. Now you should know. Earlier they were asking only about the large shell electron. Now they are asking in the middle what is happening. So whatever you have to write this electron configuration, they started this from 2020. Now in 2022, definitely they would ask a question from this for 2023. So if you are doing wrong something in this question, just go through this 20, 21 and 22 again. So they're asking this time n equals to 3. Just write the electron configuration. The principal quantum number 3 is this. So out of that, you have 2 L values. If you know the n values, L values become 0 to n minus 1. So L equals to 0 or L equals to 1. And then you have only 1 ml for L equals to 0. For L equals to 1, you have 3 ml values, minus 1, 0, plus 1. So each ml equals to 0, have 2 electrons, So altogether 4 electrons. So the second statement is also so that true. Manjula? Okay, part 3. And pink color pencil pencil. Effective nuclear charge. Number 3, the effective nuclear charge felt by valence electron of the nitrogen is greater. That is again a true statement. Carbon has only 6 electrons. Nitrogen has 7 electrons. One thing, and the other thing, radius of carbon is greater than radius of nitrogen. So both favorable for this more nuclear attraction coming for nitrogen. So that has then higher effective nuclear charge. Effective nuclear charge equals nuclear charge minus shielding effect. So that statement is also correct. So the fourth statement, I'm going to the fifth one. Electron gain energy of carbon is negative. So that is the real solid fact we already know. 2, 15, 18 positive except phosphorus. All the others are negative. So Eg2, all groups are positive. Eg1 carbon, so it is not belong to any of these groups. So that it's negative, that's again correct. Okay, so the number 4, among the ions, these 4, 2 ions closest to each other in size is K plus and Mg2 plus. See, they were given these 2. They were away from each other. How do you get this increasing order? So the third period, fourth period, 10 electrons, isoelectronic, 18 electrons, isoelectronic. So higher charge, less radius, higher charge, less radius. So you can arrange this very easily. So that has the highest difference, not the smallest. So the answer, question number 2, answer 4. Question number 3. See, I made this really nicely. With all my work together, your work, I was feeling like suffocating, but I managed everything to give you guys this best experience for the last paper. Increasing order, you can get whatever the way you want. Whatever the way you can try, you can memorize this one Or you can go with the electron configurations as well. But memorizing this is easier rather going with the electron configuration. Question number 3, answer 1. Question number 4, answer 5. Question number 4, answer 5. Question number 5. See, I couldn't find a good paper for English Sinhala medium. This is actually from Tarumini. She didn't ruin her anything. Her paper was also really nice. And thanks to NetMe again, NetMe Colombo class, Anla College that NetMe. She is the one who sent me this good structure. They say I found a couple of, but she sent me the best one. IUPAC name of the following compounds. Question number 5, answer 3. Question number 5, answer 3. Question number 6. Saturated aqueous solution, sparingly soluble salt, solubility product given, concentration is B minus is asking. How easy these questions. Just let's write the equation. I'm explaining everything to get this highest marks for structured essay and essay. If you are just going here, you can just come exactly, just come here. Mindly, you can do that mentally. So that equalizes to KSP. When you are doing MCQs, just go like that, save timing. So that equals to KSP, but otherwise you have to write all these with this physical states. Then equalize these two, get value of X, and B equals 2X. So that is twice of 2 into 10 to the power minus 3. Question number 6, answer 5. Question number 7. Number 1, the polarizability of these 3 ions increasing order. So this is the arrangement. When the anion radius is greater and the negative charge is greater, polarizability is greater, and this is the way it is increasing there because this is smaller. These two are larger, and then isoelectronic S2 minus is the smaller and has the higher charge comparing to chloride. So this is the way it is increasing order of this polarizability. So that's wrong. Polarization power, that's again polarization power, the ability of cation to distort the electron cloud of anion. This is the arrangement. When the cation radius is less and the charge is high, polarization power is high. So the highest charge is going to magnesium 2 plus, then smaller size. Charge highest is for magnesium 2 plus. Polarization power highest for magnesium 2 plus. Same charge for these two, but radius of lithium is greater. So the polarization power of lithium is greater. So this is the way these 3 are arranging the polarization power. So second one is wrong. And number 3, this electronegativity variation you guys know already. Number 3 is wrong. And then number 5, nitrogen triple bond, oxygen double bond, HF single bond, FF single bond. If you go with the radius of hydrogen is smaller, then FF together, and also you guys know this radius is greater than radius of Cl2, that because fluorine repels from each other. So that has higher radius. They were not even asking that part. So that's again wrong. Then the boiling point goes this way. So these two are non-polar. So going with the molar mass and London forces. These two are hydrogen bonding, but this is oxygen, more electronegative. So the hydrogen bonding variation goes this way. So that is the correct one. Question number 7, answer 4. Isomerism dividing into structural, stereo, structural, chain, position, functional group, stereo, diastereomerism, enantiomerism. Diastereomerism means cis trans, geometric, enantiomerism, optical. You're supposed to have this chirocarbon. Okay, so just go through whatever the given structure. Just find this geometric and cis trans. So there are 2 answers to have this double bond, number 1 and number 2, but number 2 double bond is in the terminal. So you can draw these structures. I'm going to go with this. These numbers I'm showing, I'm just going to try then only 1 and 2. Just to show that double bond comes to the middle, you can just draw like this. First, I'm just drawing the double bond. Then I'm just drawing 1 hydrogen and 1 carbon. Then another hydrogen and 2 carbon. That is the most possible. Then you are ending up here. So the only possibility, only with the double bonds, this is the most suitable because they are just giving 5 carbon, not 4 carbon. Okay, so question number 8, answer 1. Question number 9, increasing order of electronegativities. There are 4 different criteria for the exam. See, continuously asking. First, number 1, hybridization. If the hybridization equal, go with the charge of whatever the species. Same charge, go with the oxidation number of the central atom. If same, go with the nature of surrounding atoms. So first thing, I'm going with the hybridization. So I can separate these two with this. And then I'm going with this oxidation number. Charge is not there. So I can separate these two and also these two. So question number 9, answer 3. I didn't show this paper. Yeah. These are the questions that we already discussed. Moving on to question number 10. Organic compound X. You can get this very, very easily. Colored precipitate when reacting it does not given. 2,4-DNP. No aldehydes or ketones. So you can omit number 1. Treated with dichromate, Y-formed. Givens are alcohols, see. Then it is making this 2,4-DNP precipitate. Once you add this 2,4-DNP orange precipitate, so it's supposed to mean now this alcohol is converting to whatever this carbonyl. So you cannot do it. This you can get this part because now this is converted into carboxylic acid. And this is not oxidizing because this is tertiary. So you can omit number 2. Y gives a Y liberates CO2 when treated with sodium carbonate. That's this part is converted to COOH. So that can give sodium carbonate, but there are no such condition here on fourth one. C, acidic potassium dichromate, converting this to CO and this to COOH. This COOH part reacting with sodium carbonate and this CO reacting with 2,4-DNP. A little possibility is here. This can get react with acidic potassium permanganate, mean acidic H plus. A possibility is there, but you have this obvious answer, so they were not getting number 5. Question number 10, answer 3. Question number 11. Okay. Consider the following equilibrium that exists in a closed rigid container at 500 Kelvin. Which of the following describe explain effect of equilibrium constant Kp when temperature is increased to 750? And you can see the reaction is exothermic because it's the given one is negative. First one, Kp does not change. Kp depends only on temperature. Temperature changes, Kp changes. So one is wrong. Kp increases because the activation energy of the forward reaction is decreased. So the reaction is exothermic. Okay. Forward reaction activation energy is less comparing to backward reaction activation energy. That's true. But they are saying with that Kp will increase, but there is no connection between Kp and activation energy. So the sort of sounds like this sentence is correct, but because of this activation energy reason, kinetic this equilibrium constant not changing. Number 3, Kp does not change. That again we cannot accept. Reactant molecules equals product molecules. If you compare, it's always 2. But still, when the temperature is changing, Kp is changing. So does not changing, that part is so wrong. So you cannot accept that. Then fourth one, Kp will decrease. I'm going to go with this. See, if you have eagle eyes, I asked you guys to improve that from the beginning. So you can go with, so like you can see these two sentences are almost same. So you can save time reading them together. Kp will decrease because this is a backward and forward reaction is endothermic exothermic, which favors the forward reaction. Actually, 4 is totally incorrect, so that I'm going with the fifth one. I'm going to the explanation again. Let me check if some of you are. I'm just checking this only because one of you are answering. Oh no, that's Joanna. Okay. Since I need it now I'm writing the equations given by A and B. Then when you increase temperature, since forward reaction is exothermic, equilibrium. When the reaction is going backward, these are reactants. Reactants are increasing. Reactants are increasing. And C is product. And the product is decreasing. So that Kp is decreasing. So that fourth one is incorrect. Fifth one is correct. Question number 11, answer 5. Question number 11, answer 5. Question number 12. In this initial rate measuring experiments for this given equation, y gives z. That's why teachers are saying when somebody copies something, really easy to find that. See, I have forgotten this arrow. Initial rate of formation of Z in experiment 1 is R. They were saying the initial rate is R. Given that initial X and Y concentrations, okay? So, X, Y, I can write this, and they were also given these data with respect to X, order equals to 1, with respect to Y, order equals to 2, so that you can write this rate equation very easily. Then I'm just substituting these two. One is R. I'm going to get the unknown one is as R1. So that you can end up with R1 equals to 2R. Question number 12. How easy? Don't you feel like I want 50 out of 50 from like more than 10 students of the Ratnapura Colombo together, okay? Question number 12. Answer 4. 12 answer 4. 13. Is that a question? Iron oxalate, they just want this equation, this balancing equation. I didn't write these half reactions, but remember that this Fe2 plus is going to Fe3 plus. That's again a printing error. C2O4 2 minus is going to CO2. Both are oxidizing, MnO4 minus reducing. So this is the way you can write this equation. This is 3 plus, okay. So anyway, they were given the mass divided by molar mass, number of moles, then 5:3 ratio, multiply 3 divided by 5, number of moles of potassium permanganate, given that concentration, divide by the concentration. I multiplied by 10 to the power minus 2 to convert this into centimeters cubic. Question number 13, answer 3. 13, answer 3. Okay. At a given temperature, a certain number of moles of H2S gas was inserted in a evacuated cubic container, and they say the volume is constant 1 cubic decimeter. Given temperature mean temperature is also constant. System was allowed to reach the equilibrium, and then they were showing this reaction once they reached the equilibrium. At equilibrium, it was found that the fraction equals to x, then the altogether it's supposed to be 1, because they are talking about a fraction. All the fractions together equals to 1. So I'm going to get initially, they are supposed to be 1 mole of H2S. If you have 1, fraction is supposed to be x. Then this is become H2S 1 minus x, but 2:2, and dissociation is supposed to be x here. But if x dissociated, since 2:1, this is supposed to be x divided by 2. So that 1 minus x, and x divided by 2, initial is 1. Then the question, they are asking the Kp. They want us to get this expression for Kp. Normal path I'm going to find this molar fraction, then the partial pressure, then write the Kp. Both sides pressure are different, but they are giving the pressure as total pressure as P. Okay, if you get all these together, total number of moles become 2 minus x divided by 2. Then I divide each of these by 2 minus x divided by 2. Then those are these. Then the total pressure is P. Molar fraction multiplied total pressure is the partial pressures. then get the partial pressures, then write the KP expression, substitute, and you can simplify, get the answer. Question number 14, answer 3. I'm a little nervous now. I'm a little getting nervous because I don't want you guys to do mistakes here. I want you guys to tell me that I got 50. Okay. Moving on to question number 15. So question number 14, answer 3. 14, answer 3. Moving on to question number 50. pH curve obtained for a titration of 25 cubic centimeter of 0.1 m cubic decimeter unknown acid. Again, 0.5, 0.1, 0.1 unknown base. And here the volume is 25 cubic centimeter. At the given, and it is showing here, most appropriate regarding the this titration, that you can see two evidence are there. Acid is not stronger because they were not starting from 1. So acid is supposed to be weak acid because it is around 3. So it is around 3. One evidence. The second evidence, so the exact solid evidence, this is in between 7 and let's say 11, 8 and 11. So 8 and 11. So that acid part is weaker. So the acid is supposed to be then weak acid. And the other thing, drastic pH range during the equivalence point, the volume of base is 25. So 0.1, 0.1, 25, and 25. So both base and acid supposed to release the same amount of H pluses. Here they were only getting, like, let's say dibasic, acidic, that's also possible, but they were not giving that answer. They were only giving the monobasic. So then acid is monobasic, base is monoacidic, and monoprotic. Base supposed to be strong base, and the acid supposed to be weak acid. Same concentration, same volume. H plus of acid equals OH minus of base. Drastic pH range is between level 8 and 11. Weak acid, strong base. So the solid evidences are there. Question number 15, answer 5. Which of the following statement is false with regarding the elements of S and P block? Although C known, yeah, it's inert, but it is possible. See, I have given all these different oxidation numbers, compounds that we did for Unit 2 and Unit 6. Among the hydrogen halides, HF has the highest bond dissociation energy because it has the lowest radius of fluorine. Number 4. Among the group 1 metals, lithium to cesium, cesium has the lowest melting point. That's because of this metallic bond strength. Radius greater, metallic bond strength is weakest. So correct. Oxidation number of NH2OH is -1. That's again correct. The solubility of hydroxide of group 2 elements decreases. That's wrong. It is increasing. Solubility of sulfates are decreasing because sulfates going down the group are precipitates. When the lattice enthalpy is greater, they are making precipitates. And hydration or dissolution enthalpy is greater, they are more stable in aqueous. So that's how these two occurring. Question number 16, very famous statement. Answer 3. (17). I wanted you guys to talk to me after this and tell me how you were feeling about this paper. I didn't have even time to get down to talk to the students that day. Anyway. Okay, the temperature is constant at 25 degrees Celsius. Acetic V1, sodium hydroxide V2, and concentrations of acetic X moles per cubic decimeter, sodium hydroxide Y moles per cubic decimeter. And then they're given two different data. X is X is smaller than Y, and V1 is smaller than V2. So if you go with this multiplication, X into V1 supposed to be smaller, Y into V2 supposed to be greater. So that number of moles of sodium hydroxide is less than number of moles of acetic. So that obviously this has this buffer action. Okay. So they are asking the pH of the final mixture. If you want, you can go with Henderson too. Concentrations written, volumes written, then number of moles written. Then since we know already that sodium hydroxide is less, hang on. Oh, sorry, this is the other way around. This is the other way around. Because the first side is acetic. Oops. I think again I did this wrong way. Here what you're supposed to write is, I'm sorry guys, I'm confusing you. This is CH3COOH and this is NaOH. Sorry, this doesn't have this buffer. Sorry. Okay, this cannot have buffer because it's obvious this is greater. It's obvious this is greater. Okay, moving on then. So that YV2 is greater. YV2 is greater than XV1, so that N sodium hydroxide remains. So the sodium hydroxide is a strong base. pH controls only by sodium hydroxide. And then the total volume become V1 and V2. Knowing the number of moles, now we can calculate concentration of sodium hydroxide. So the remaining sodium hydroxide become the difference between these two. And so that divide by the V1 and V2, that's by cubic decimeter to convert it to cubic convert this into cubic decimeter, multiply by 10 to the power minus 3 to get the concentration moles per cubic decimeter. So that this is the sodium hydroxide concentration remaining, but they are asking pH. So get the minus log 10 of that. So I'm just writing minus log 10, this expression, but they are asking pH. Again, pH plus pOH equals pKW. So pH equals pKW minus pOH. pKW minus, so this is the pOH part. I'm just writing that. Then minus minus multiply becomes plus, so that this is the answer. Okay, let me show you the full paper. I'm in a class now. I'll ring you in the evening after class. Okay. Okay, then definitely you're going to change this little thingy here. I can leave this. This is acetic. This is sodium hydroxide. Okay. Question number 17, answer 2. Question number 18. Which of the following statements is incorrect with regard to the reaction given below? So they were given this full reaction, and for the reaction, whatever the given reaction, enthalpy is minus 483.7. Since it's minus, it's exothermic, so energy is releasing. So they are just playing with your mind. For 1 mole of reaction, 1 mole of reaction mean per mole. They were given that per mole. This is the value that we can accept. Given reaction release 483.7 kilojoules per 1 mole, that's true. 2 moles of H2, it is just the same. Consumes mean using energy. H2 is consuming, consuming is using as H2 and evolving energy. The total sentence is correct. Water 2 moles, true. 483, true. Evolving, all are true. For the reaction, see, the given reaction and this reaction is, the connection is multiplied by 2. If you multiply this by 2, see, you are getting the answer. That's again true. For 1 mole of O2, in this same reaction, you have 1 mole of O2. So it is just going with the way as they have planned. So it is not half. This, if you get this, minus 483 divided by 2, that is half. For that, they are supposed to be half O2. For the equation, they were using 1 O2. See, they are trapping you, but very easy. I know you guys are really, really talented. They can trap you now because you have my way of thinking now. 19, galvanic cell, that we know everything about the galvanic cell. I have drawn it here. So this is actually enough for you. You don't need everything. And zinc anode oxidation, negative. Copper cathode reduction, positive. And this is electrochemical cell. Delta G equals minus NF E naught. So E naught is supposed to be positive too. Delta G become negative so that the reaction is spontaneous. Cell reaction is spontaneous. Cell produces electric energy, electrochemical. Reduction half reaction, cathode. Oxidation, anox. Cathode negatively charged. No, cathode is positively charged. Question number 19, answer 3. And for your practice, I'm just saying electrons are going from here to here, anode to cathode. Current is going the other way around. Question number 20. Lone pairs on bromine delocalize so that they are getting these negative charges. But here it's showing the positive charge. 20. Positive charge on bromine is correct. Here the positive charge inside the ring is incorrect. Question number 20, answer 2. Real gas tends to ideal gas at very high temperature and very low pressure. Question number 22. Okay, I'm going to go with the explanation. Two identical close, rigid, close. We can go with this, nothing going in and out. So the equilibrium, maybe they can maintain. Rigid mean volume is constant. Standard temperature and pressure. So the pressure is not changing and temperature is not also changing. So we can say T, P, V all are constant. 1 mole of H2, H2 1 mole. And so I'm just giving the molar mass of H2 is 2 grams per mole. So MH2 is 2 grams. And they are having 2 moles of O2. Oxygen molar mass is 16, but I have given here O2 molar mass. So that here MO2 is 32 grams. Okay. First part, both H2 and O2 have the same average kinetic energy. So kinetic energy, we don't want to think about anything other than temperature. E bar equals 3RT over 2. As long as temperature constant, kinetic energy is not changing. So that is the answer. You found the answer. I'm cold. And number 2, H2O2 have the same average speed. No, the heavier one, less speed. See the heavier one, less speed. Same mass. No, 2 grams and 32 grams. Same density. How come I didn't write that part? I think I forgot that. Volume is constant. Mass is different, so density cannot be same. Density is supposed to be different. So 4th is also incorrect. Both same effusion rate. This word effusion, I think we didn't use this word that much, but in my note, I think I saw this word once. They get this word effusion, then I was just talking like effusion and diffusion. Spreading out a substance from high concentration to low concentration is normal diffusion. But effusion mean if you are using some sort of a pressure for that, simply mean the diffusion path is smaller than free path. Diffusion or spreading of substances through a narrow path. So that is called the effusion. Anyway, it is just going from one place to another place. We know the factors affecting diffusion. So effusion is supposed to have go with the same factors. Let's say we never done that, but still, you know, it is like going from one place to another place. So the same factors. Surface area, high, the diffusion is high. First time ever, we are talking about this diffusion in this advanced level chemistry. From 1970s to today, they were not talking about these factors affecting diffusion. Concentration gradient, temperature, when all these are high, diffusion is high. Molar mass, lower, diffusion high. Density, lower, diffusion high. Then we derived these two little equations. If you remember that we did for theory, and this is the first time we are talking about this. Rate is inversely proportional to root m and inversely proportional to root density. So that molar mass is changing this way. The molar mass of hydrogen is smaller, so the diffusion rate of hydrogen is supposed to be greater then. So 5th one is also incorrect. Anyway, since we have this very clear answer, to answer 1. See, they were supporting us to get the correct answer. Let's say that this effusion and diffusion, whatever this thing, the knowledge of students is less. But now you guys have this. Concentrate well. They would add this more to next year. Netmi was asking me like harder questions are getting more marks. If you do harder questions, you are getting more marks. No such things. It's totally depending on how much marks they are giving to that part. Even the question is easier or harder, it's not increasing your Z score unless you are just writing that part. But they can make like MCQ structured essay and essay. They analyze. I've sent you these pictures to your WhatsApp groups. Once they analyzed, when they found out the question is really good, correct question, but students were answering very low. So then they are just editing that question. Then they are repeatedly using that question to target these weak students. So that's how they are doing. So that's why always they are having this connection. So that question number 22, answer 1. Moving on to 23. Who's texting continuously? Oh, 23. Okay, first thing they are asking, dissolution of S, X solid. Solid goes to aqueous. Dissolution is 70. That is my first equation. Then the number 2, molar enthalpy, molar entropy of X is 100. So just for X, if you go with only this solid, you guys know that enthalpy can be 0, but entropy has some sort of a value. Only for solid. So that is just 100. Then if you write this entropy for the reaction, that's supposed to be the product entropy minus reactant entropy, but the product is X aqueous. For this reaction, X aqueous, I'm just going to get as X aqueous, and the reactant is X solid. That value they are given as 100. So I'm just going to substitute that. And for this total reaction, delta S reaction is given as 70. Question number 23, answer 5. Answer 5. Arrowheads, minor products, all these 3, and here the arrowhead is strong. So secondary carbocation is more stable. So bromine gets there. That's a major product. Marconic of secondary carbocation. Question number 24, answer 5. 25. Gaseous equilibrium, constant temperature taking place in the closed system, doubling the pressure. Why we worry? As long as constant temperature, equilibrium constant depends only on temperature. Constant temperature case constant, so remains the same. Question number 25, answer 3. Okay, 26. They were not given these reactions between magnesium and nitrogen. Those two, formation of magnesium nitride and formation of lithium nitride, I'm just going to get as equation number 1 and 2. So the magnesium nitride and lithium nitride react with water and it is releasing ammonia. You guys know that. A mixture of 3 moles of magnesium metal and unknown amount of lithium metal was reacted completely with excess nitrogen. They were just given this ammonia mass. They were asking initially how much lithium is been using. Magnesium with nitrogen, magnesium nitride. Lithium with nitrogen, lithium nitride. 3 moles of magnesium they were using. The stoichiometry between magnesium and nitride is 3:1. So that from the 3 moles of magnesium, it is making only 1 mole of magnesium nitride. We don't know how much lithium, but still lithium is 2. Lithium nitride is 1:1. Okay, so those are my first and second equations. 3 and 4, they were given as data. Then this 1 mole of magnesium nitride, 1:2 ratio giving 2 moles of ammonia. So we can calculate the mass or the number of moles. Since the stoichiometry of lithium nitride and ammonia is 1:1, let's go with that with the calculation. So they were given the total ammonia mass divided by molar mass, that is 2.6 moles. 2.6 moles. Magnesium nitride ammonia equals 2 moles. So that the remaining become 2.6 minus 2 means 0.6 moles. And stoichiometric ratio between lithium to lithium nitride is 3:1. And lithium nitride to ammonia is 1:1. So then lithium to lithium nitride supposed to be again, ammonia to lithium supposed to be then 1:3. Ammonia to lithium. See, 1:3. 1:3. So that the number of moles of lithium becomes 0.6 multiplied 3, 1.8. But they're asking the mass, multiply with the molar mass of lithium. Question number 26, answer 3. Moving on. Question number 27. Ammonia can be synthesized at high temperature as shown by this unbalance. So we have to balance that. Once you balance, it's very easy. Just you only need to balance this hydrogen, but I'm not happy with this 5 divided by 2. So I multiply this equation by 2 to get to this full number equation. A maximum of ammonia gram that can be synthesized from these given. So let's go with this limited factor thing. Stoichiometric ratio is 2:2, 5:2. Let's see. We don't want masses. Mass divided by molar mass, we are getting number of moles, 1.5 and 6. Finding the limited factor. 1.5 multiplied by 5 divided by 2. 3.5, but we have 6, so that's enough. So the limiting factor is NO. So the total NO is supposed to reacting. If they are asking us to show this, we're going to show that, but they were not asking us to show this. Is an MCQ, so I'm not going to go through the other way around. I'm just know that now the limited factor is NO and it is using its full then. So it simply means the total 1.5 NO gives 2:2 mean 1:1. See, same amount of ammonia that multiplied by the molar mass. So question number 27, answer 4. No, like එක සැරේ කරන එක ඒක ලේසියි. Okay. Like
Oh.
okay, so came for a second. Question number 27, answer 4. 28. At a temperature, E naught cell equals E naught minus E naught cathode. Let's read the question first. E naught cell of these two reactions, they were given two reactions, and another reaction that 2H2O2 gives H2 and O2 occurring in the electrochemical cell, they were given that E naught as 0.55. They're asking this E naught 2 value. So what I'm going to do is I'm going to rearrange these equations to get this E naught 2 equation. Okay. As a data, they were given this. Then we need to find which one is oxidizing, which one is reducing. One's supposed to be the anode and the other one's supposed to be the cathode. If I write the first reaction, they were given as E naught 1, so I'm going to get that equation as number 1. That O2 goes to H2O, and that so that is the reduction. Then the next one is the reaction between O2 and H2O2. This is equation number 2. Then this is supposed to be the oxidation. Let's see. I'm writing this equation number 2 the reverse way. And then if I multiply that by 2, so that I can cancel off these 4 electrons and 4 electrons. Now, H2O2 minus 1 is going to this 0, and that is the oxidation. So this is the oxidation. Because we had to write this the other way around. Because the given reaction, that this reaction, H2O2 is the reactant. So we have to start from that H2O2. That's why I have written this equation the other way around. Okay, H2O2 is the reactant. So if we go with this and this together, we can derive this one. And that is this. Clear. Same equation we are deriving. Therefore, equations in the main cell reaction. So the two half reactions are these 1 and 2. Using 1 and 2, we can derive this equation. Okay. So first equation gives H2O, which a product of cell reaction. That is a reduction and cathode. Second should reverse, since in cell reaction, H2O2 is acting as the reactant. So that's going through the oxidation. That's supposed to be the anode. So that E01 is the cathode, E02 is the anode, which equals to, by substituting values, we can write just subject E02, you can get the answer. Question number 28, answer, Afra. 28, answer 4. All right. Moving on to question number 29. Major product, sodium borohydride, cannot reduce esters. So ester part is just maintaining. It is not reducing the double bond as well, selective. So it is only reducing CHO to CH2OH. 29, answer 5. 30 again. See, the reaction coefficient is continuously they are using now. They were given all these values. Temperature 25, Kc value is given. Just calculate QC and it goes like this. Now QC is greater. Reaction favors to backward to reduce O3 and increase O2. Question number 30. The amount of O3 gas decreases to reach the equilibrium because QC is greater than Kc. See, very nicely they were explaining the answer here. Question number 30, answer 3. 31. For a given chemical reaction, which of the following are affected by the temperature? Collision frequency of reactant molecules. When temperature increasing, kinetic energy increases, movements increases, so the collision frequency. Collision frequency. Number of collisions per second per unit volume is increasing. Kinetic energy of colliding molecules. Yeah, temperature increasing, kinetic energy with the temperature increase, whatever the molecules. Enthalpy and activation energy. There is no connection between temperature and these two. So that the question number 31, A, B correct, answer 1. Question number 32. This is the mechanism. This one polarizes here. And then this chlorine joins here. So this plus charge is coming onto, because this is giving electrons, so a plus charge is coming onto benzene ring. And FeCl4 minus is the sort of actually intermediate, okay, not the final product. Final product is FeCl3 plus C, this compound. Which of the following are formed while this reaction? While FeCl4 minus possible, I'm going to the answer. This is definitely possible, plus charge not possible. And this plus charge on the chlorine, and again two chlorine connected, that's again not like weird this, and this is possible. Plus charge on this next one, adjacent carbon, that is possible. Hydrogens are, let it be, all these hydrogens are there. At the end of the day, these hydrogens are leaving. So, yeah. 32 AD correct answer for. Oops. 33. All answers are there, so I'm going with this explanation. At 24 degrees Celsius, 1 cubic centimeter aqueous solution of lead iodide in equilibrium with excess solid lead iodide contains lead 2 plus concentration A. Correct statements are asking. The amount of lead 2 plus will be 2 moles when the volume is doubled. It's saturated. A moles of lead 2 plus mean 1:2 ratio. 2 moles of I minus supposed to be there, and they're saying the volume is 1 cubic decimeter. So that this is these two are the equilibrium concentrations. Concentrations are not changing with the once you even add the volumes, because this system is saturated. Okay, they are saying excess solid lead iodide is there. Excess solid lead iodide means the solution is saturated. B, concentration of lead 2 plus aqueous will be 2 moles per cubic decimeter when the volume is doubled. No, it is not changing. This is definitely A, this is definitely 2A, it's not changing. Hang on, let me explain this thingy. Now they are saying in 1 cubic decimeter, you have A moles. In 2 cubic decimeters, if you double the volume, in that volume, twice the moles, that is 2A. That's possible. Clear that? Okay. So 1 cubic decimeter has 1A. 2 cubic decimeters supposed to have 2A. Okay. But the concentration is not changing. That's why I have written here in the underline here within bracket. Saturated mean molar concentrations are not changing. B, even the new volume is 2 cubic decimeter. If you divide 2 by 2A, that's again 1 moles per cubic decimeter. That's not changing. So B incorrect. C, the amount of lead 2 plus aqueous will decrease when the small amount of sodium iodide. Sodium iodide with the common ion effect, adding I minus. So the reaction favors backward to decrease I minus, so that lead 2 plus is also decreasing. So that statement C is correct. D, the amount of lead 2 plus aqueous will be A divided by 2 when the volume is doubled. No, you already know that. D is incorrect. Question number 33. The amount of lead 2 plus will be A over 2 mole when the volume is doubled. Is it possible? Have you gotten these answers correct one? Volume doubled. To A. The amount of lead 2 plus will be 2A mole when the volume is doubled. A over 2 mole when the volume is doubled. No. If A is correct, it simply means D is supposed to be definitely incorrect. Definitely incorrect. Okay, question number 33. A, C correct, answer 5. A, C correct, answer 5. 34, correct. D block elements, fourth period, Cr2 or 3 is expected to react with strong acids and strong bases, Cr2 or 3 amphoteric. So it is reacting with both, so that's acceptable. And you can show these reactions as well. Sodium hydroxide is added to solution contain these. Precipitates are insoluble in excess sodium hydroxide. Dirty green ferrous hydroxide, yellow-green ferric hydroxide, manganese hydroxide beige, nickel hydroxide green. All are metals do not dissolve in excess sodium hydroxide because they don't have amphoteric property. H2O2 and O2. Yeah, under acidic condition, both are producing from H2O, it's producing O2. C correct. IUPAC name is actually, I don't know what part they have taken that. You can say that's correct because that is, all the stuff are correct other than this little thingy. And that is this IDO part. But so far, even without this, they were taking the answer as the correct answer. But make sure when you are doing this, just write this exact, not chloro, but chlorido. All the other parts of this question is correct. So we cannot say that this one is incorrect. A, B, C, maybe D is correct. Question number 34, answer 5. 34, answer 5. 36. 35. Which of the following statement is correct? Boiling point of, okay, I'm going to go with this explanation again. Okay. They are given 4 different conditions. First one, propanoic. Hydrogen bond is greater than this alcohol. So the boiling point is greater. And this is London forces, both are non-polar. Molar, this is the surface area is greater. So molar, both non-polar, London forces, this is surface area. Surface area, so that B is also correct. Then C, butanol, butanol, this hydrogen OH, see how I have done this, like when I'm writing, I have done so many mistakes. This has hydrogen bonds, so that butanol smaller boiling point is greater. And the last one, hexane and pentanol, hydrogen bonds, that's again, pentanol is greater. So that question number 35, correct answer 1. 36. Which of the following statements are correct regarding the nitric? A, B, C, D. I'm again going with explanations. Dill and conch nitric oxide as acting as oxidizing agents. I've given a couple of examples. It can oxidize metals, even dill or conch. Thermal decomposition of ammonium nitrate gives N2O and water. So the B is correct. NO bond of HNO3 all equal in length. You are making only 2 here. So you're going to get a plus charge as unstable. To make this resonance hybrid, only these 2 are participating. So only 2. This is not same. This bond is different. So that incorrect. Carbon does not react with C. Carbon is reacting. So I'm showing the reaction. So D incorrect. 36. A, B correct. Answer 1. 36. A, B correct. Answer 1. 37. I'm again showing this. In 15 kilometers from Earth, you have a troposphere, and then 50 kilometers stratosphere, 85 kilometers mesosphere, and ozone layer is in between, just right after troposphere, 20 to 35 kilometers away from the Earth. You cannot say only 37. Let me read this. First one, it is a region in the upper atmosphere where ozone, yeah, all are correct other than this part only. That's why this statement is incorrect. It is not only ozone, because there can be other gases, and you know this ozone having this equilibrium with O2, definitely we know that O2 is there. It is a region in the atmosphere where atomic oxygen is abundant. That is true because they are going through this UV decomposition to give this atomic oxygen to make O3 from O2. It is a region that prevents ultra radiation. Yeah, it is a region where ozone breakdown only occur via a chlorine free radical. No, there are other free radicals as well. Also, UV radiation can deplete ozone layer too. So that's not correct. Question number 37. B, C correct. Answer 2. B, C correct. Answer 2. Moving on to 38. All the information given organic layers of 100, that 100 has this method 0.125 m. Out of that, they were taking only 100 cubic centimeter. Then they were taking 50 cubic centimeter and titrate with 0.2 m HCl, 15 cubic centimeter. Let's calculate KD. I think I'm done again wrong here. Okay, this is supposed to write the other way around. This is HCl. This is CH3NH2. Okay, CV of HCl given. So CH3NH2 still the same, but that's in 50 cubic centimeter. But then we have to calculate how much in 100 cubic centimeter. So you have to multiply that by 2. That is 6 into 10 power minus 3. But the total they were adding is this. They were adding 0.135 cubic centimeter. That is 13.5 into 10 to the power minus 3. Then the difference is the amount in distributed to 75 cubic centimeter of organic layer. So that amount is, this is 75, is 13.5 minus 6 equals 7.5. Then actually this 1000 is not necessary. I'm just multiplying to convert this to cubic decimeters. Just dividing 75 and 100 is enough. So anyway, you can get the answer very easily. KD equals 1.67. So that A, partition coefficient KD between these two equals 1.61. That is correct. 4.6, that is wrong. If you go with C and D together, so now this, if you write the KD expression, organic divided by aqueous, that is greater than 1. And also volume of aqueous is greater than volume of organic. So that less volume having more number of moles dissolving. So that it is dissolving more in CH3NH2. In organic layer, CH3NH2 dissolving more in organic layer. So that AD correct. 38 answer 4. Answer 4. Moving on to 39, that again I have all these explanations. I have written everything like this, so then you can understand things really nicely. 39, which of the following statements are correct regarding the dissolved oxygen level in water bodies? Composition of dissolved oxygen in water is the same as that of atmospheric oxygen. So in water, it is 9 ppm. But in gas or atmosphere, it is 21%, like 5. If you just go with the fraction is like 1/5 of this. So the composition of O2 in water depends on other abilities, like, how much O2 can be dissolved in, like temperature, chemical compound, and also on. So that A is incorrect. Then B, dissolved oxygen level in water decreases due to eutrophication. What is this eutrophication? Excessive growth of algae due to addition of nutrients to the water. Due to growth of thick blanket of algae colonies on water surface, it prevents penetration of sunlight to lower layers of water bodies. This prevents photosynthesis, so that decreases oxygen concentration of water. Yeah, so by the eutrophication, oxygen concentration decreasing too. See, H2S could be produced in water. Yeah, that's even we talked under this unit 14, but oxygen, when the water level, oxygen level is lower, not high, it's lower. In anaerobic condition, it is happening. When dissolved oxygen level decreases, it creates anaerobic conditions. Then anaerobic bacteria react on dead debris of aquatic animals to oxidize sulfur-containing compounds to H2S. So the best explanation from the resource book I've gotten for you guys. So C is incorrect. D, aquatic plants contribute to the dissolved oxygen level in water. Yeah, photosynthesis increasing dissolved oxygen level. That is definitely true. So question number 39, B, D correct, answer 5. 39, B, D correct, answer 5. 40, they are continuously asking this little, they were adding this very little thingy to this new resource books. So they are just asking questions from that. 40. Which of the following statements are correct regarding industrial processes? 40. Coke, a raw material used in the extraction of iron by blast furnace, functions only as a reducing agent. See, these are because they were asking this question continuously, so I added all this knowledge to one single place. As reducing agent, directly it is reacting with ferrous oxide reducing to iron to produce carbon monoxide. That is the main reducing agent, so it is by burning as a fuel to generate heat. See, carbon dioxide plus carbon gives carbon monoxide. Carbon plus oxygen gives CO2 plus heat. So A is incorrect. B, a raw material used in the extraction of magnesium can be regenerated using a byproduct formed during an electrolysis step. Yeah, we use chlorine. Dow process, bittern from sodium chloride production, we are using, there are 5 steps. Production of calcium oxide by calcium carbonate. Then using that calcium oxide, we deposit magnesium hydroxide as hydroxide. That production of magnesium chloride by dissolving that in HCl, making the magnesium chloride. Then separate magnesium chloride and then filter, dry it. Then electrolysis of magnesium chloride to produce magnesium by the reduction. Then this Cl2 producing during this 4th step, they are using to make this HCl. Then that HCl is using again back to 3rd step. Be correct. In the manufacture of high purity TiO2 using rutile, inorganic impurities are removed in the chlorination step. Production of TiO2, chlorination, oxidation, recycling of Cl2. So during this chlorination, TiO2 reacting with carbon to produce titanium solid, that titanium solid reacting with Cl2 to produce TiCl4. During the oxidation, that TiCl4 again oxidized to TiO2. Then recycling of this chlorine back to produce this TiCl4 is using. So C is correct. Then D, nitric. Iron is not the catalyst. Ammonia with oxygen, rhodium, platinum, rhodium indicate catalysts are using. Then to produce NO, that on NO again oxidizing with atmospheric O2 to produce NO2, that NO2 with water and O2 produce this nitric. And the percentage purity is 96%. The yield is 96%. So D is incorrect. Question number 40. BC correct answer 2. BC correct answer 2. All right. See, this little thingy, they were added this little thing about this these 4 compounds in this new resource book. See, each year they are asking one question out of that. Acidic strength is this way. That is true. But remember, the oxidizing strength is the other way around. Oxidizing strength is the other way around. The last year they were asking that question. So the first statement correct. That's because number of chlorine in terms of the with the oxygen. See, when the oxygen increases, that's when the middle oxidation number is increasing. That's when they are showing more and more acidic nature. So releasing H plus is then easier when they are having less electrons for the middle or central atom. So it has the explanation. 41 answer 1. 42. Gaseous gas react with acidic solution of potassium dichromate elemental sulfur forms. Yeah, we know the reaction. Gaseous gas can act as a reducing agent in acidic medium so that it get oxidized to sulfur, reducing dichromate. Explanation is there, 42 answer 1. 43. An electrochemical cell based on the reaction can be used to generate electricity. Any reaction going through the redox, theoretically we can say, can act as, any redox can act as like anode and cathode, so it can produce electricity because the electrons are passing. Cl2 gas is strong oxidizing, so it oxidizes I minus to I2, not the reducing. Second statement is wrong. 43 answer 3. 44, Grignard with water producing this RH. Last time they had this CH3, MgBr producing CH4. This time they were just given again RH. Same questions. Not alkane. They are not producing alkanes. Sorry, alcohols, not alcohols, underline alcohol. First statement wrong. A carbon atom of the carbon magnesium bond in the Grignard reagent has a partial negative charge. So that's why the Grignard is acting as a nucleophile. 44 answer 4. Second statement correct. Moving on to 45. While disonium salt formed from aniline are stable at low temperatures, disonium salts from the primary aliphatic amines are unstable at these temperatures. Yeah. Lone pairs of electrons on the nitrogen atoms of aniline is delocalized on the benzene ring. That's true. Explanation. What is the explanation? The reason is supposed to be disonium salts plus charge is delocalizing within the ring. It's not explaining here. They are talking about aniline's lone pair. See, they are trapping you. 45 answer 2. Be alert, you have the knowledge. 46. Enthalpy change would be 0. Ideal. Yeah, ideal is 0. And this is a condition. No intermolecular interactions. That is why enthalpy change becomes 0. So 46 answer 1. pH is 4. If you dissolve this carbon dioxide, pH equals to 5.6. But when you dissolve acids, it is less than that. So that is called the acid rain. It is not 6.5, it's supposed to be 5.6. Lowering the pH, not only these two, but also CO2 can do this. CO2 is also acidic gas, not the acid rain. The second statement just asking the lowering the pH than 7. By carbon dioxide, it is lowering to 5.6. So wrong. 47 answer 5. At a given temperature, half-life of a first order reaction is given by this. How easy? That is true. First order reaction, see, this is directly the theory, and I have given this one. I have given you guys a question, but within that question, I given this little explanation within bracket, asking if they go more and more, what's going to happen. So first order reaction, so this its T half is independent from initial concentration. So they are saying after 150 seconds, T half is 50. Then first 50 is 1 T half. Second 50 mean when it is become 100, 2 T half. Third 50 mean 150, 3 T half. Then 100% become, 50% become, 25% become 12.5, 1, 2, 3 T halves. So remaining is 12.5. So the completion become 100 minus 12.5, 87.5. That is true. But there is no connection between these two sentences, independent two sentences. 48 answer 2. And the 49. In the manufacturing of ammonia, we don't use this 600, we are using 450 optimum, 450 optimum temperature. Activation energy of ammonia gas produce equilibrium reaction of the Hebbe process decreases with the increase in temperature. No. This connection is there with the reaction speed with the temperature, but activation energy is not changing with the temperature. Both statements wrong. 49 answer 5. Bakelite is classified as bakelite, phenol, formaldehyde, giving bakelite plus H2O. Remember that is a condensation polymer, not addition polymer. But it has this 3-dimensional structure. I was feeling a little bored to draw that structure. I would do that later, maybe sometimes. 50, incorrect, correct, answer 4. Moment of truth. Come on, make me happy. Please, please, please. Wow, so cool. Okay, others. Sarah, darling, I want you to tell me which questions are wrong. What are the wrong questions? Another 2. What can you say? What can you say for third one? What are those questions 40 and 45? A 40th question. Oh, still the less knowledge of industrial, I guess. 45. I think 45 is a silly mistake. Because they are talking about aniline. I think where you did the mistake. Okay, others are waiting for answer, waiting for how many MCQs are correct? Afra and Ramudi. I'm gonna kill you, Zara. And this time is more than enough to get this little extra knowledge for unit 14. Don't give up, okay? Going to 50 is like miraculously making you happier. If you are in this 45, 46, it simply means your second paper is perfectly correct. So almost like you are reaching 50. Then 50 plus 47 means 97. That is not 100. So make sure that you are doing correct with this, all these questions. Okay, Afra and Ramudi. Okay, I'm going to go through so you guys can give me your answers later then. And I hope all of you would give me your answers because this is the last paper that I can analyze you. Manjula. Manjula. All right, I'm moving on to structured essay. Manjula, charge it again. Charge it. එකයි මට ජූස් එකකුත් ඕනේ. Okay, moving on to structured essay. Question number 1. State whether the following correct. Lyman series n equals to 1. That's UV. Oh, sending me text. Make me happy, make me happy, make me happy. Afra. Wow, Ramudi. Oh my God. I love you, darling. Oh my God, finally you did it. Oh my God. OMG. Let me feel this a little. Ramudi, I want to tell you something about Afra. Impressive. First time mage student kenek in this class. During theory classes, that's the first time they were taken 50 marks. I'm so happy. Ramudi 50. Zara 47 and Afra 45. What can you expect? What can you expect you from me? Or what can I expect more than this from you? I'm so happy, I'm so glad, and I love you all. Just give me a second, I'm drinking my juice. OMG. Afra, what do you feel? How do you feel? I'm going to give something definitely to this student who's made me happier with 50 marks. But still, I'm really happy for Afra and Zara. You guys are impressive, really, really impressive. I'm so glad that I could be able to become your teacher. Even with all the challenges I was having in my life because I'm doing this, my higher education, I did it again, I guess. Let's hope for the best. If you've done the other 2 subjects nicely, reaching beyond these 29 positions of deep now is really, really easier. I don't care this district ranking. I only care about the island ranking. All right. I am expecting more and more 50s from other students as well. Let's see. Okay. First one is true. N equals to 1, it's UV. There are only 10 electrons in calcium. See, they were asking these 2 MCQs, and they're asking it here again. Calcium atomic number 20, 1s2, 2s2, 3s2, 4s2. L equals to 0 mean S. So all these 4s is 8 electrons, not 10 electrons. So that's false. I'll show the answers again after this explanation. N2O has 3 structures. You know this. This is one of my best something explanation during I did when we were doing unit 2 for these very fresh students going through this resonance and Lewis and everything. So that is true. Number 4, yeah, if you go with the second period, that's fluorine. If you go with the third altogether, that's fluorine. But here they were asking about fluorine. So that just get us, that is true. Here they're asking about fluorine, okay. Fifth one, chlorine. Molar mass is greater, London force is greater, so the boiling point of chlorine is greater, so that's false. Down the group, first ionization energy is decreasing because the nuclear attraction is Going down the group, radius increasing, nuclear attraction decreasing, so that the ionization is decreasing. Oh, don't I have this page? 1, number 10, 11, 12. I think I have it. I have it here, but it doesn't have these answers, I guess. Yeah. Oh, no, it's there. Yeah. Okay. I didn't do anything load to you this time because this time I first finished English paper. So everything is there. But I found this structured essay part later. That's why it took a little time until let me given this. I didn't do this low quality ones. Okay, these are the answers. True, false, true, true, false, false. 4 marks for each. Then the next part is asking to draw this Lewis. And then they're asking these shapes and oxidation numbers also. Bent, -1. Sulfur pyramidal, +4. Then they're asking other resonance structures. You can draw only 4 resonance structures, keeping double bond 1, 2, 3, and 4. 4 resonance structures. They are not asking us to state this stability. Wow, I'm so happy. I'm really happy. You all made me happy today. I don't like that only 3 students are here, but I can't help it because I think students are struggling with other subjects. That's what I'm thinking. Now they feel like chemistry is done, but chemistry is not done. Trust me. You have to hang in here in chemistry if you need this higher Z score. Because we done a good job here. Okay. So C1, 3, trigonal planar, SP2. Let me know if I am done this printing errors again. 3, trigonal planar, SP2. Next one is N3. 4, tetrahedral bent SP3. N4, 2, linear, SP. What? Let me check. Yes, darling. That is a printing error. That's why I want you guys to check. This is bent. This is bent. Don't pay. Moving on. Okay. Pi bonds are only 2p because they have only the second period carbon and nitrogen. Check all the others. Again, I want you to check my printing errors as well. In 2022 class, 2021 paper, I did only to 2022 students. There was a fresh paper like 22 for you guys. Then Tharumini was showing me all this because we did class physically. Okay, then see here I have written it correctly. Trigonal planar to bent. Trigonal planar 120 bent so that it is less than that. You can write 119, 118, 117 or so on. Then tetrahedral to bent. So it is less than that. Tetrahedral mean it is 2 lone pairs are there. So it is 104. Linear SP, this is exactly 180. But even if you write 181, 179, they were accepting. This is only going with the hybridization N3, N2, N4 because all are nitrogen. There are no difference between elements. Okay. Increasing order, ionic character, polarization power of anion because only anion is different. How easy. Then the next one, bond angle, square pyramidal 84.3, bent 104, linear 120. Ionic character, ionic radius, third period, these are fourth period, and isoelectronic. Number 4, I have drawn this. So solid triple, solid double, and this is solid single. These two goes with resonance. This is 2 resonance, so the pi bonding character is greater. But here pi bonding character is less, 1/3. Here it's 1/2. Here it's half. Here it's 1/3. Okay. Number 5, first ionization energy. I was going only with this lithium, nitrogen, and fluorine. So I have written lithium, nitrogen, and then fluorine. Adjacent to nitrogen, I have to write phosphorus. Then adjacent to nitrogen, I'm writing phosphorus. Then when I'm moving to this third period, magnesium is less than phosphorus. Then magnesium comes right after phosphorus. Or you can go with beryllium, like beryllium is greater than phosphorus, supposed to be smaller than that. You can, whatever the method you can use. All right, these are the answers. This question is a little parts they were asking is little like, you know, like they were asking little extra stuff. I know that, but getting answers for this question is really, really beautiful. Because all these answers, I think that's why they were like jumping on clouds. They were bouncing on clouds like when they were talking to me right after the exam. See how easy these questions. Oh, okay, I'm going with first thingy. Lilac flame, that's to potassium. And a purple color solution and purple flame test. Lilac flame test, all these together. I'm gonna go with again. This is supposed to be purple color solution. This is supposed to be KMNO4. And again, if you check this 1:4:1 ratio, you can satisfy that too. So A is supposed to be potassium permanganate. Then same 3 elements, green color. Green color potassium salt is potassium manganate. So B is K2MnO4. Then moving on to C, they say it is viscous and also disproportionation. So this is hydrogen peroxide. So that C is hydrogen peroxide. By disproportionating, they are giving H2O. That is then D is water. Brown precipitate with when C is added to a solution B. Potassium, they were not taking potassium permanganate. Solution B, they were taking this K2MnO4. So that is potassium manganate. But still you have to accept that permanganate +7 or manganate +6. That's really all right. But still it is reducing to MnO2. So E is supposed to be then MnO2. Then moving to F, hematite, Fe, I didn't check actually this one. Is it FeO or Fe2O3? So that has iron. I have this little problem, like, could you sort that out? This is ferrous sulfate. Hematite is ferric oxide. Number 10, I want your explanation for that. So the white precipitate with SO4 2- with barium. So it is barium sulfate, barium insoluble in dil H2SO4. That is barium sulfate. So this is supposed to be ferrous sulfate. Then this precipitate G is barium sulfate. Then they were given again these all the instructions, like, you know, the brown coloration along the wall of the test tube with ferrous sulfate all together. So the brown ring test, NO2 or NO3, these anions. And then they say not evolving gases with Dil H2SO4, no gases with Dil acid, that is definitely nitrate. Then the yellow color flame is sodium. So that it's supposed to be sodium nitrate. Then they're asking, so this is the part you want to remember. Sometimes you have forgotten this one. This is the complex they are forming, the brown color complex during this brown ring test. And then the J is a little different. This is not only calcium sulfide, calcium oxide. We can go with both. Either calcium sulfide is white or calcium oxidate is white, because both are giving these gases. Whatever they are saying, and both are decarburizing potassium permanganate. So we can go with both. J can be any of this. They were taken actually this one. Later they come up with this H2SO3 as well. Sulfurous acid. Okay. So these are the answers. And then they're asking these questions. Check your equations as well. Check them. Any of these are accepted. Okay, it's not all. I have written like or just one equation is asking. And also either oxalic or either sulfurous. That's again only one. All right, moving on. Then acidified solution of CMene H2O2 potassium permanganate H2O2 reaction. This, just check your answers. These four. Oh, Zara or Ramudi, once you've done the class, I want you to give me any particular explanation why they were using FeSO4. Acidic medium or something little is there. Okay, moving on. See how easy this answers. Moving on to next question. They are first asking this connection. Temperature constant. So this is actually Boyle's law. Connection between PV when temperature is constant, that is the Boyle's law. Then they want us to show that density is proportional to pressure. Two different methods I'm showing. Both are acceptable. PV equals nRT. PV equals M over mRT. Then I'm getting this V this side. M over V is D. Then subject D. All the others are constant. P is proportional to D or D is proportional to P. You can go with both. This actually is a Boyle's law. All right, moving on. See, they are just keep asking very simple theory stuff. Simple theory. See, inverse relationship that we did for theory. And when you increase the temperature, thermally expanding these volumes, so the you are getting this, you are shifting the graph to top, shifting upward. They were given 10 marks or 0. 10 or 0 marks, no parted marks for this one. How is this again? Okay, just add these two together, cancel off whatever common, then you can end up with same equation. 1 plus 2 gives 3. Then again, two graphs were given. See, concentration and rate. The other one is constant when you are taking this straight line going through the origin. So the answer is graph 1, a straight line going through the origin, 5 marks. Order with respect to ozone is 1, 5 marks. A straight line going through the origin, 5 marks. Order with respect to O gas equals to 1, 5 marks. Total order equals to 2, 5 marks. Total order equals to 2, 5 marks. Then you can just write this straight expression like this. Oops. Derive the units of K. Just substitute K, so just subject K, ozone and oxygen, moles per cubic decimeter. So you can cancel off 1. This is going up. Per mole decimeter to the power 3 per second. Then all the information given, they want us to calculate the value of K. Just subject K. Get the answer very easily. They were given these two separately. Now we know this power is 1. Can cancel off this to this. So this become K. Again, I've done this mistake. This is plus. Plus. Because the structured essay part, I copied from the Sinhala medium one because I first did the Sinhala medium. I found the Sinhala medium before English medium one. All right. Answer question number 4. Hydrocarbons having molecular formula C5H10. No, geometric isomerism. Okay, C5H10. Alkenes. No geometric isomerism mean no cis trans. So that there's supposed to be this terminal double bond. So I can go with only these 3 structures. With terminal double bonds, I can draw only these 3 structures. Then just go through, you can get the answer very easily. Both A and B are chain isomers of C. That is possible. C, A, B, C, these 3. Chain is only different because they have same functional group, same position. It's not changing. When A and B are repeated, reacted, separately treated with cold concentrated H2SO4 and then heated, DE producing, I'm going with both together. A and B with concaste SO4 and heating produce T and E. So addition of OH group. So these 2 are the products, but I don't know which one is what. So I'm just going with all these 3. D and E. Only D shows optical isomerism. C, then this is D, so that this is A. Okay, we figured that out. A and B gives the same compound F with hydrogen nickel. Okay, I'm going to add hydrogen nickel to all these 3. But I can see 2 compounds are giving 1. Then we already got this is A. Then the other one who made this F, this is supposed to be B. Then this is definitely C. Rest of the part is just go through this to get this. Okay, check your answers. Then HBr in the presence of alkyl peroxide, that is a H with sodium hydroxide, or Br converting to OH, that is I. That's easier. Okay, DEI, secondary, tertiary, and primary. So I, turbidity after, so E, tertiary, instant turbidity, D, turbidity after 10 minutes, I, turbidity after 24 hours. Then here, you cannot, they are giving only 1 mark for Lucas. To get all these 3 marks, you have to write zinc chloride concates. Yeah, see, I'm keep asking you, even if you write for your easiness for the practice, you need these names, but they're asking the proper reagents to get the correct answer. correct marks. Okay, this, check your answers. Alcoholic KOH elimination. Nitric sulfuric, that is meta NO2 because COH is a meta director. And HBr, electrophilic addition. HCN, that's nucleophilic addition on CO group. KCN, bromine gets away, CN joins, that is nucleophilic substitution. With that, they're asking these three. Nucleophilic addition 4, electrophilic addition 3, elimination 1. Okay, can we move on this essay answers? Okay, what is the difference between these questions? If you go with the very first question, all these answers are extremely easy. But see the question number 5, how long is that question? Like a lot of stuff are asking, a lot of answers are there. Easy question. So I'm keep saying they are targeting 2 stuff. Maybe questions are anyway harder. So only some can get through. Easy questions, if you go easing your mind, then you are losing time. So if you feel like question is easier, then get this idea, something tricky is supposed to be here. The main part comes with this timing. So I would go with timing. I would definitely go faster. Have all these in your mind, okay? 100 marks is not a dream for you now. For you all three, now I see you guys. I know there are a lot of other students, they are sending me their marks always about like 43, 44, 45, so on. Since you guys are only here today, I'm just saying you all three are really promising for 100 marks. Keep it up. Consider the reaction H2I2 gives 2HI. Initiated as HI, 0.45 moles. Volume is 1 cubic decimeter, but that's constant. Evacuated rigid container. So volume is constant. So they once temperature is 800 degrees Celsius, 0.05. Okay, the first calculate the equilibrium constant Kc. 1. So dissociation can just write. Initial, you're going to go with this moles per cubic decimeter because volume is 1 moles per cubic decimeter. Since this volume is 1 cubic decimeter, you can write this same amount of this number of moles as concentration. See, this 1 mark is for unit. This 1 mark is for unit. Don't forget that. Anyway, so they are saying NH2 initially is 0.45, 0.45, and this amount remaining is 0.05. So that 1:1:2 ratio, 0.05 remains 0.05 H2 as well. Then the dissociated amount, this is the remaining amount, become twice of that because this is 1:2. So that 0.05 multiplied 2 is the remaining part. So the form part become 0.45 minus 0.05 into 2. That is 0.35. It is a little weird because usually we are getting always this part is smaller, but here this time this part is larger. See, it's little different, so, but who cares? So just write the KC1 expression, 4 marks. Substitution, 3 marks plus 1. Answer, no units, 1 mark. 49, 3 marks, no unit, 1 mark. Okay, separate similarly container. They are saying KC1 is this. Equation number 2. When the two containers are connected using these two together, so this third equation is occurring. New equilibrium constant for KC3 for third equation is asking. See, how many times we did this? How much time how many questions we did? I did to improve you guys starting from 1970s. Have fun with those. KC1, KC2. First equation multiplied by 2. So I'm making it equilibrium constant become power. If you multiply equations, equilibrium constant become power of that. Then if you subtract 2 from 4, so you are getting this equation they're asking. So division, subtraction means division. KC1 squared divide KC2. It's KC3. So just KC3 equals KC1 squared divided by KC2. Just go with these answers. From part 1, we found this KC1. KC2 given as a data. So get the answer. 2 into 10 power minus 5 moles per cubic decimeter. Okay. So this is, if we write the KC3 expression, this is known, this and this given, only unknown is this I2. I just subject I2, just get the answer. That is 2.5 into 10 power minus 5. 2.5 into 10 power minus 5. Okay, part 4. See, an extra 2.5 into 10 power minus 5 they are adding. Rest of the part is still the same. 2.5, 1.25, 5 into 10 power minus 5. But here we found already 2.5 into 10 power minus 5. They are again adding another 2.5 into 10 power minus 5. Now the total initial after addition of new I2 become addition of these two together, that is 5 into 10 power minus 5. Then do the substitution, get the answer. I just want to tell you guys, did you get this answer? Just say yes, somebody. QC3, did you get this answer? 5 into 10 power minus 6. Yes or no? Sarah. Ramadi or Afra? What is the answer? It is 1.25 into 10 power minus 5 or 6. Can you send me a picture of that part, please? Is it this way you did this? Ah, Ramudi. Oh, that's why. That's all right, darling, but you're not missing everything. You are missing but marks for these numerical values. All the other marks are getting, but numerical values marks are not getting. Ramadi, if you get this answer, or if you've done everything correctly, but still the answer is different, so I want you to send me a picture, okay? Anyway, so on this numerical value, all the others are correct. I'm a little confusing here. Something is a little different from this marking scheme, but I didn't go exactly with that. I just want to clarify that with you all. So anyway, see if you compare these two. QC, KC is greater than QC. So 2, KC3 equals to QC3, equilibrium point of above reaction shifts to right, favoring forward reaction. Again, when you're writing to this thingy, they are giving 4 marks. And forward direction, they are moving on to forward direction. Here again, they are giving 4 marks. What do you think of these ones? See? Okay. This is the initial condition. So that you had some sort of a equilibrium. That is that equilibrium. We did this HI, I think you remember. Then they were adding extra 2.5. See? This is, so we can go with this calibration actually, because we have these 4 values, 5 values, 2.5, 2.5, 0.125, 5 and 5. Then I'm just going to calibrate this like 0.12, like, 1.255, 7.5, and then the completely 5 is, okay, 2.5 and so on. Then this become 0.125. Then here you are adding, you had 2.5 into 10 power minus 3, that is this thingy. Then to that you are all of a sudden adding another 2.5 into 10 power minus 3. Then you are moving to see the same 5 into 10 power minus 3. See that, so that this become your HI initially what happened. And then these 4 are like, normally you can write, this is the HI initial. And then H2, remember, see, this is H2, SH2S, 2.5 into 10 power minus 3. That is again here. And then my last one is this one, S2. This. Then what happened? So the reaction, we have added HI, reaction is go forward. S2 supposed to be increasing. See, S2 is increasing. So then this is new one. And also HI supposed to be increasing. That is again a product, reaction is going to forward. So that this is increasing. So this is the second equilibrium. And this is decreasing, not lower to the initial. So that I2 initially this decreasing, but not getting lower than initial. And this is also decreasing, H2 with I2, since the reaction is going forward. H2S also decreasing, H2S decreasing. How beautifully you can do this. I know we have the full knowledge now. Okay, I can go with both these methods. I'm going with this equation. I'll show the equation method first. They were given these again. If I question again. Here I have showing all these 1, 2, 3, 4, 5. You can see these pink color numbers. So they are using continuosities. So I have given numbers 1, 2, 3, 4, 5. Same. Then 4 and 5 are these two, 4 and 5. So that I'm just leaving 4 and 5 this way. So the next reactions I'm just going with. Okay, and again the Sixth one is there. Another equation is there for B part 3. I'm just not going to go with 6. Then rest of the equations I'm building up. I'm going with 7, 8, 9, 10, 11, 12, so on. So I have this clear then idea about these equations I'm going with. Of C part 1. Using the data given below, calculate enthalpy, entropy, and Gibbs free energy of this reaction number 4. They were given some other data as well. Those two equations, H2 plus I2 giving 2HI. That equation they were given earlier, H2 plus I2 plus 2HI. For that equation, they were given H and delta. That is the solid one, okay? That is a solid one. That is my equation number 7. Then again, they are given another one. That is my equation number 8. I2 solid 2, I2 gas. Those are two of these equations. Okay, see the difference. This is how HI gas, I2 gas, this is I2 solid. Then again, they are giving another data, I2 gas to I2 solid separately. I just need this H2 gas, but I don't want this I2 gas. So I need to add this so that I can cancel off I2 solid. Then I can go with I2 gas here. So what I'm doing is I'm writing this equation, the reverse. That's for your easiness. You can do directly. You can just write minus 8. I2 gas, I2 solid. That is my 9th equation. If I add 7th and 9th together, that you're going to get equation number 4. So I'm doing same thing for delta H and delta S. Once I get this delta H equals minus 10 kilojoules per mole, delta S equals 150 joules per Kelvin per mole, delta G equals delta H minus delta S, but that's not conditions. Temperature is 300 Kelvin, then I can directly add this delta G not 4. Minus 55 kilojoules per mole. Minus 55 kilojoules per mole. Okay. Okay, if you're done with this thermochemical cycle, you can go like this. Okay, part B3. Using the answer B1 and B2, the given reasons other reaction 6 is spontaneous or not. For HI. Hang on, before that, part B2. Another part is there, part B2. Using the data, So this is the fifth equation, equation number 5. Again, for this one, you need to calculate the same. Or they were given all these data, the data H2 gas, entropy, enthalpy, again, formation enthalpy. So I'm going to go with the state function method. See, they were given 4 marks to write this equation. See that? Using that, you can get delta H5 equals 167, delta S5 equals 90, then minus delta H minus delta S, delta G naught equals 140 kilojoules per mole. Got it? Okay. Then part 3. They are giving another equation, that's equation number 6, and we can derive that equation number 6 from B1, equation number 4, B2, equation number 5. If you multiply equation number 4 by 2 and equation number 5 to that, you can get 6 equation. So I'm going to do same to this delta G as well. So I can find the delta G equals to plus 30 kilojoules per mole. So that is plus delta H plus 4 marks. So that reaction is non-spontaneous, 4 marks. Obviously they are getting marks. And still it is not done. Still it is not done. Regular. Better get used to these kind of answers. KSP, AgCl, Ag2CrO4 given. Initial chloride and chromate concentrations given. We are adding silver nitrate to that. Let's see how much silver needed for both separately. So I'm writing these two equilibrium equations. Then I write the KSP for these two. Then get separated this, subjected this silver concentration. Silver concentration for the first one is 8 into 10 power minus 9 for AgCl. For silver chromate, it's 2 into 10 power minus 5. Less needed for AgCl. Since silver plus aqueous needed to precipitate, AgCl is less than silver plus aqueous needed to precipitate silver chromate. AgCl solid precipitate first. Okay, see this. Since silver plus aqueous needed to precipitate AgCl is less than silver plus aqueous needed to precipitate Ag2CrO4, they were given 2 marks for this. AgCl solid precipitate first, they were given another 2 marks. See, always the partition of these marks are going continuously. Concentration of Cl minus. At the time, I don't even want to read these questions. These questions are like, you can see these questions. What is the next part of this question is coming? You can just imagine. So when Ag plus concentration is less, is greater than 2 into 10 power minus 5. 2 into 10 power minus 5. Then Ag2CrO4 starts to precipitate other than AgCl precipitate. So the minimum AgCl, silver plus for precipitation of Ag2CrO4 is this. Then we have to go with to find how much Cl minus. Cl minus is in KSB AgCl. Let's write KSB AgCl. Then subject Cl minus. KSPAgCl, Cl plus concentration is this. So that's chloride. When right at the moment starting the silichromate, chloride concentration is 8 into 10 power minus 6 moles per cubic decimeter. How easy and how beautiful. Question number 6. Only sodium acetate given. Equilibrium reactions. If you directly write CH3COONA, giving CH3COOH plus NaOH, only for this one, they were given marks as well, then 8 marks, but we don't do that. We do this way. So if you write these two, they were given 4 marks separately. This KH is not that what we learn for equilibrium, Hendricks constant. They just want to get this this equilibrium for this equilibrium reaction, equilibrium constant KH. So that for this one, we are writing this. That's why I'm writing to these equations separately. You can get these answers very easily. So they are given 4 marks for that. If the dissociation constant Ka and Kw, they want us to just prove this one. See, directly theory. Then you are writing this KH we have done separately. Then we are writing for this one. That's for, this is Kw. And if you write this upside down, 1 over K, 1 over A, that's for dissociation of acetic acid. And that's for Ka. This is for Ka and this is for Kw. Then if you multiply these two together, then you are only remaining become the part of this KH. Only these parts are remaining. So this is the connection. Part 4. Ka given, Kw given. They want us to calculate KH very easily. KH equals 5.56 into 10 to the power minus 10 moles per cubic decimeter. Moving on to part 5. This time they did a little difference. Usually they are going with, for when you are drawing all these pH volumes, they are going with this any acid or any. This time they were using this salt and acid. Okay. Salt is 0.1 M25, titrate with 0.1 MHCl. What is the volume of 0.1 MHCl required to endpoint? And pH, what is the pH at the endpoint? The equivalence point they're asking to find volume. So this is the reaction. Sodium acetate with HCl gives acetic and sodium chloride. That's how the medium is getting acidic. Then Cv of sodium acetate given. And this we don't know, let's say 0.1 into V into 10 to the power minus 3. Then 1:1 ratio mean these two are supposed to be equal to each other. 0.1, 0.1, cancelling 1 minus 3, cancelling off. So 25 is V. So VHCl is 25 cubic centimeter. Then this is the acetic acid remaining in the medium. To find the pH, we need this concentration. So this is the number of moles. Total volume is 25 plus, now this 25, that is 50. Divide that number of moles by a volume, 0.05. Now this is the initial concentration of acetic. Then this acetic 0.05 dissociating X and X. Oswald dilution law 0.05, X is very small. Let's write the Ka, then subject X. You can get the answer very easily. Then get the X, which is the, oops, I accidentally did that. Oh. You guys are sending Afra. You guys are sending messages too. That's what happened. You guys are sending messages too. Tab. That's why I didn't see them. Only Zara directly sent it to laptop. That is what happening. That's why I didn't see that Ramudi's and Sarah's, Afra's marks. So that X is P, see X is H3O plus. Get the minus log 10 of that. pH equals to 3.02. It doesn't matter even they were not given marks for this. Who cares that? You just have to write. You just have to write. They are giving marks as long as you are not writing that. Once you start to write that, they are not giving marks, but it is a must to write. They want us to sketch this titration curve. It's not necessary to count these values. Just get this idea, but yes, sort of curve. Anyway, let me explain this. So you need the initial pH. This is a reaction. So that you have the sodium hydroxide in the medium. So initial pH is supposed to be greater than 7. And some sort of acidic is also in the medium too. So that this cannot reach just normal sodium hydroxide. This is supposed to go between 8 and 9. But if you want, you can calculate. The real value become 8.87 if you have calculated. They were not given marks for that. Equivalence point is 3.02 that we calculated. So when the volume of HCl is 25 cubic centimeter, final HCl is just the given concentration 0.1. Then the final pH is supposed to be 1. And also H plus is reducing from CH3COH, so it's supposed to be less than 1. So the drastic pH range for strong acid weak base is 3 to 7. This here the midpoint is 3.02, and since you are not using directly weak base, you are using this sodium sort of sodium acetate, weak acid. So this is going between less than 3. It's supposed to be, because otherwise we can get the midpoint at 3.02. Then 3.02, get the midpoint as that. It doesn't matter. It doesn't matter what usually we do. But this is going like this. Okay, y-axis, x-axis marking initial pH supposed to be greater than 8, or it is a bit between 8 and 9. And this is less than 1. And this is the equivalence point. And the pH range supposed to go between, like, you know, let's say this 2 and 6, so on. To give the shape, because you're adding HCl, initial solution is basic. So with everything, they were given 10 marks for this. Okay, any acidic indicator we can use. Methyl orange, 3.1 to 4.4. This is 3.02. Bromophenol blue is not possible 3.02 and 4.1 is away. So the best indicator is 3.7 and 3.2 is closer than 4.1. So the best indicator is methyl orange, and they were also taking the methyl orange as well. Then they're asking, why can't you detect this endpoint when you are using? This is acetic weak acid, ammonia weak base, explain that. Titration, no drastic pH, which the color change can occur. Since no suitable indicator exists, difficult to detect the endpoint. Just write everything. They were given 6 marks for that. Ideal binary solution. How easy? They want us to show that P naught A equals 5 P naught B. Given that initial condition, XA 0.2 means 1 over 5. So XB becomes 0.8 mean 4 over 5. For easy calculation, I'm going like that. The second condition, temperature constant. XA and XB are half and half. Initial pressure P changes to final pressure 5P divided by 3. Then for Raoult's law, just to write this equation, they were given 3 marks. And write in Dalton's law of partial pressure, this equation, they again given 3 marks. Then write the partial pressure according to Raoult's law. Then add these two together to get this total pressure of the system. Then here, this is 5 over 3P. I can equalize these two sides if it is 5P. So that this equation I multiply by 3. Just to avoid these 5 in these fractions, I'm multiplying this by 5. So that anyway, I can end up with 5P and 5P, both sides equal. So I equalize these two so that only P naught A, P naught B remaining. So you can get this connection. All right, part B. Composition wave pressure diagram. The vapor pressure diagram is asking, now I need which one is greater, which one is less. So which one is greater? P naught A is greater because P naught B has to multiply by 5 times. Let's say if this is 20, P naught B, P naught A is 100. 20 multiplied by 5. So this is what they're expecting them. Then see, they want us to again mark P naught A, P naught B, total pressure, PA, PB. They were given marks for those. Compression of the liquid phase at the point where PA equals PB. What is that point? PA equals PB point mean the cross line. See, only at this point, these two are equal. So PA equals V naught AXA, PB equals V naught BXB. XA and XB comes together, it's a little frustrating. So I'm going to make this XB equals 1 minus XA. Then I can equalize these two. So I can write P naught A XA equals P naught B into 1 minus XA. Then P naught B into 1 minus XA, I can just multiply P naught B by these two. That's become P naught B minus P naught B XA. Then we know this connection. P naught A equals 5 P naught B. As a data they were given from the first part, we need to calculate, we need to show that. Then I'm just gonna use, instead of this P naught A, I'm writing 5 P naught B. Then on the unknown is P naught XA and P naught B. Simplify, P naught B cancelling off. XA 1 over 6, 1 minus 1 over 6, XB 5 over 6. I want you to do this paper 5 times. I am finishing everything ahead of time. I'm so sorry, like I'm doing everything ahead of time, but these students are struggling with the other 2 subjects. And I'm giving these instructions from the beginning. I think it's not your fault. These other teachers, they have to encourage you to go with like faster. Then you're not having these issues. Can't help it, I guess. Otherwise, you guys are really talented, still having issues with other 2. See this one. How do you know which one is the anode and which one is the cathode? See the negative and positive. The higher negative one is always the anode. So anode, anox oxidation, that is this A. First one. Then the cathode, reduction, red cat. So, sorry, second one. Anode is second one, cathode is the first one. Or otherwise, delta G equals minus NF E naught. In galvanic cells, electrochemical cells, it is spontaneous. To be delta G naught negative, E naught is supposed to be positive. You can go trial and error. Cathode minus anode, anode minus cathode. You don't know, 1 minus 2 or 2 minus 1. Still, you're supposed to get this positive E naught value. If the E naught value is positive, then you should know that's spontaneous. So that is the direction. So either method 1 or method 2 you can use to get what is the anode and what is the cathode. Anyway, they are not expecting these explanations. So first one is cathodic half reaction. Reaction 2 is the anodic half reaction. Then anode oxidation, cathode reduction. Just you have to write anode as oxidation. Okay. Then add these 2 together to get the cell reaction. You have to multiply this by 2. This equation you have to multiply by 2. Then E naught cell equals E naught cathode minus E naught anode. E naught cell equals 1.23 volt. 1.23 volt. Very easy, very simple parts are there asking then. Part 4. So the cell operates up to cell operates within 600 seconds. And exchange electrons are 4. We have to multiply this by 2. So 4 electron and 4 electron. Exchange number of electrons during this cell reaction is 2. So this is a cell reaction. During that, total electrons exchanged during the cell reaction is 4. So 2H2 to 4 electron. 1:2. Number of electrons per 1 H2 mole is 2 moles. Number of moles of electron passed through cell becomes so that 2 moles. Calculate the number of moles of electrons which pass through the cell. Calculate the amount of electricity in Coulomb generated in the cell during its operating. Because as a data, they are saying number of moles of H2 is 1 mole. So we have to calculate this per 1 mole, okay? Per 1 mole of H2 is asking. Okay, that we know per mole, electricity become 96,500. But now you have 2 moles, then you have to multiply this by 2. So that the total amount of electricity generated in the cell become 193,000 or 1.93 into 10 to the power 5 coulombs. So this current is constant. Time is 600. Q equals IT, I equals Q divided by T. So the current they are asking, I equals 322 ampere. And part 3, amount of the current drawn. Then this little thingy, they're asking you to concentrate well. This part is sort of little new. Just continuously get the practice before this exam, okay? Our exam, our day, victorious day. In the galvanic electrochemical cell, propane is used instead of H2. Now H2 become propane. This is the anode. And they were using this basic condition. They were using OH minus, but even H plus, that's all right. Using H plus, that's all right. So how do you balance this? Half reaction is asking the products they are saying carbon dioxide and H2O. Okay, I have shown these numbers. How do you balance? I have 3 carbon. So 3 carbon dioxide. Then 8 hydrogen. So 4 H2O. Okay, then how do you add this redox part? This is not oxygen. Now we are having this OH minus medium, okay? And the oxidation number, okay, if you go with like separately, if you want, you can calculate. You have 8 plus charges on this. So there are supposed to be only 8 minus charges all together. So the oxidation number of this carbon together is -8. And for carbon dioxide, we know for 1 carbon, it's +4. This is the first time we are doing this. So that, but we have 3 carbon now here. So +4 multiplied 3, that is +12. And this is -8. So that this has oxidized by -8 to +12 by losing 20 electrons. By losing 20 electrons. So that I'm writing oxidation by 20 electrons. So that I'm adding 20 electrons here. Or otherwise, now I have how do I explain that? 20 OH minus. To complete this or to quench these 20 electrons, the negative charges I'm using is this OH minus. So this time if I'm adding 20 electrons, I have to neutralize that by adding another negative charge. In the medium, we have only OH minus. So then I'm adding this 20 OH minus. This is totally different the way we did. Then 20 OH minus gives this 20 oxygen and 20 hydrogen extra. So to quench that, I need to add another 10 H2O here. Then when you balance 10 H2O plus this 4 H2O, when you balance, so it is fully balanced. So this is in the basic medium. Or In acidic medium, you can do this, like you are adding then another plus 20H plus, so that you are making 20 water, cancelling off water here, so that you can end up here. Even acidic or even basic, they were accepting this. See, this is little complicated, this balancing of this equation. This is the way you have to balance. Memorize this method. If I explain again, okay, the first thing that you can go with like normal balancing, only this is making this and this, but this is not a normal reaction. If you consider this as a redox reaction, they have to go with these electrons. How many electrons? Here all carbon has -8. Here all carbon has +12. So it's 20 electrons. So 20 electrons are releasing. Then to balance that, you're going to add 20 OH minus. Then from that 20 OH minus, how many oxygen or hydrogen you're adding extra, that part you're adding here. Derive the balance equation from the overall cell reaction using, now this is the anode. I'm just writing anode here, and then the cathode. Now I have 20 electrons and 4 electrons here, so I multiply this by 5. I have written these orange parts. Then you can cancel off these. Then you can write the full cell reaction. Oh, you can name one. All right, then part 3. Giving reasons, state one environmental advantage of the cell which uses H2 gas over the propane. First cell, this is a reaction. Second cell, so wrong. Only release H2O 4 marks. Release CO2 4 marks from the second one. CO2 gas contributes to the global warming, which cell 1 does not contribute or do not contribute. 2 marks for that. So that's all for first part 7A. Seven B, X, D block element. It's not necessary to do this, but if you have time, I know you guys are having time, so you can just write these elements, 3D, fourth period. X with dill HCl, colorless solution X1, HCl with metals, metal chloride and H2, elements above hydrogen in electrochemical series, manganese, iron, nickel, and zinc. I have the little idea. Ammonium hydroxide, ammonium chloride with H2S group 4. White precipitate, that is definitely zinc. Even if you cannot get this point, definitely you can get zinc sulfide point. And again, they are giving this information reacting both with acids and bases, HCl and sodium hydroxide. That again has the amphoteric property, that is definitely going with zinc. Then ammonium hydroxide, excess sodium hydroxide, sodium zincate, excess ammonium hydroxide, tetraamine complex. Now, to when you to explain why X1 is colorless. See, for that, you are showing this electron configuration for S0, or there is no 4s, just going to show that. Then let's write, to occur colors, there are no D1, D9 partially filled d orbitals in zinc 2 plus ions. All d orbitals in zinc 2 plus completely filled. You have to write everything. Then X6 IPAC name, tetraamine 2 space. What is this name? See my page 57. Tetraamine zinc 2 space. Tetraamine zinc 2 space ion. When you are writing things nice. All right. Space ion. And that's what I'm saying. They were just repeatedly asking sort of the same questions. Oh, where did I leave my... Give me a second. I can't find my stylus. I just put it somewhere just to get the tip backs. And I have lots of pens here. Yeah, found it. 7B. 2. Again, Y, D block. Same row, fourth period. 2 common oxidation status, oxidation numbers. M is the larger one. Pink color species. Pink can go with cobalt or manganese. But then they are talking about these oxidation numbers. 2 common oxidation numbers, that is for cobalt, +3, but manganese has 4 common oxidation numbers. So we can go with cobalt. If you can try manganese, it is not working. If you try manganese, it is not working, and especially see it is not giving this amines complexes with ammonia. So you can come back and check. Anyway, so YN plus then supposed to be cobalt 2 plus. Then this is a pink color Y1. At sodium hydroxide, cobalt hydroxide pink. Then basic medium H2S cobalt sulfide black. Ammonia, yellow-brown ammonia complex. Atmospheric oxidation, it is going from +2 to +3. That is a brown-red one. Then with HC, blue color chlorido complex. How easy? How easy the life? Okay, check your answers. Tetrachlorido cobaltate 2 space ion. Who's texting me? Next, you don't. Usually we say, but they were expecting that. And this is, even if you have one single oxidation number, this is not traditional. This is IPAC. We are always giving the oxidation number. Understood? IPAC nomenclature, we are always giving the oxidation number. Extremely easy. Chain extension. 3 carbon and 4 carbon and this part. 3 carbon part here. 4 carbon and this part is here. If I go with colors, see this part is this part. So the connection has come here. So with the reagents they were given, we can go very easily. Sodium acetylide and alkyl halide. Okay, so I'm adding Lindler / H2O, barium sulfate, palladium H2 quinoline. Then triple bond become double bond. Addition of HBr, making this bromine. So this pink carbon I'm just showing here, this carbon is now here, joining. Then this is terminal alkyne sodamide. So you are making this sodium acetylide. See, this carbon is joining with this carbon. The pink carbon is joining with blue carbon. I'm showing that. The rest of the part is easier. So triple bond convert into CO, HCSO for deal H2SO4, sodium borohydride and methanol, giving the final product. Or you can add Lindler at here. Then deal H2SO4 to go there. That's also possible. What is the question again? And Joanna, you are not having like last couple of weeks, like you were not having this enough connection. But I know you are really talented girl. So I want you to not to give up, okay? Just hang in there. You can talk to me anytime, even Liana, Vihas, Ramsey. Okay, so the next part, F. Oxidation, addition of 2 for D and P. They're asking, what is this G? This is G. Couple of methods are there. You can check your one. I'll just show the standard one they were using. Friedel-Crafts, alkylation, oxidation, FeCl3Cl2, then meta, then CH2 or COOH to CH2OH. You can go with this acylation as well. And this one also is possible. Moving on. Less than 3 steps they're asking to convert this compound into this aldol. See, 2 compound, 2 carbon, 4 carbon. Just go through aldol, but for that you need to convert this into alpha hydrogen, this carbonyl, then reduce this to OH. Either you can use lithium aluminum hydride, ether, and water. To this part C, product is this. COCl, sodium hydroxide, COONA. Just show this negative and positive. Then they're asking the mechanism. OH minus comes and joins. Is coming back, leaving off Cl. Then you're coming here, addition of sodium hydroxide, you are getting here. See, they were given even 1 mark for this Cl minus as well. And addition of, with sodium hydroxide, they are making the final compound. They are not given marks for the final compound, but they were given marks for this sodium hydroxide. See, 3 marks. It's really tricky. So they're expecting you to write everything. That's why I'm keep asking you guys just to write everything. Just write everything. So whatever the way they are giving marks, like biology now they're changing the chemistry. I guess they can find this way to cutting down these talented students. Nine. You can go with all the methods that they are given, so you can end up here. First thing I'm going with this, they are saying this is colored, some sort of a D block supposed to be. Then this is colorless, then some sort of a white, and then D aqueous. Number 4. Then with DIL-HCl, acidic gas, that acidic gas with dichromate converted to green mean, reducing gases. So these gases can be SO2, H2S, and NO2. Then sulfide thiosulfate, sulfide or NO2 minus can be the anion of one of these. Okay. I'm gonna stop there. Then I'm moving to, they're saying dill ammonia, green color. That's possible with nickel or copper. Addition of ammonium hydroxide, excess dark blue. So nickel hexa, copper tetra can't help. Unfair. Then to get this more idea, group 4, black color, cobalt sulfide, nickel sulfide. Okay, then this cannot be copper. So this is nickel. A has nickel as the cation. This is the anion. We're going to come to that later. Then silver nitrate, white, dill ammonium hydroxide soluble. Soluble mean this is supposed to be silver chloride. It is making this silver chloride. I think again I haven't tried that. Amanisa AAGC yet. Okay. Then this one, lead nitrate, white color lead iodide, heating soluble. That's again chloride. Then dill H2SO4, white precipitate, dill HCl insoluble, sulfate soluble, insoluble in dill HCl is barium sulfate. To confirm that, flame test, green color barium 2+. So now we have nickel and chloride and barium. So barium chloride, we can complete that part. Still we are missing something with A. We know this A has nickel, but and I am supposed to get from any of these. Then to find the anion. E is a gas, E gas. Let's say E gas is NO2. Then if it is a nitrite, no precipitation of any of these nitrites. And they are not talking about a turbidity. So it cannot be sulfite. Sulfides are also these compounds. A lot of these sulfides are water soluble. Then we can end up with sulfite here. Anion is supposed to be SO3 2 minus. If you write the equation, you can end up here. Barium sulfide is precipitation. Barium sulfide is aqueous. Barium sulfide is a precipitation. So here again we can avoid H2S as well. H2S as well. See then the answers. We have ferrous oxide, ferric oxide, and inert. Fe2 plus, Fe3 plus, and inert. Conc acid 10 cubic centimeter to dissolve. So Fe2 plus, Fe3 plus, and inert. Add more water to convert it to 50 cubic centimeter. That's just the playing with you. You always go from 50 to 10. Then CV of potassium permanganate. Then once done with that, pH is 10. Potassium permanganate has Mn2 plus also. So that Fe2 plus convert into Fe3 plus ferric hydroxide precipitate. Mn2 plus converting to manganese hydroxide precipitate. Here molar mass as I have written here. That precipitate mass is this. Equation number 1 occurs here. Fe2 plus MnO4. Stoichiometry is 5:1. Then 2 and 3 equations. Fe3 plus make ferric hydroxide. Mn2 plus make manganese hydroxide. KMnO4 reacts only with Fe2 plus. So KMnO4 CV for into 10 to the power minus 4 from equation number 1, stoichiometry is NFE2 plus to NKMnO4 5:1. See, they were given 3 marks for that. Just write those. Just write those. Each year they are improving their marking scheme so that I'm improving my notes as well. Just do like this, okay? And so 5 times is Fe2 plus. That is 2 into 10 to the power minus 3. But Fe2 plus to FeO is 1:1. Then number of moles of FeO is still the same. Multiply with its molar mass. Calculating molar mass, they are giving 2 marks also. So that is the mass, but the initial mass is 0.48. So to 100%, that is 30%. All right, let's see Fe3 plus. Precipitate mass equals ferric mass plus manganese mass 0.5706. But Fe2 plus number of moles equals FeO number of moles, which equals 2 into 10 to the power minus 3. We already calculated. But that's supposed to be the number of moles of ferric hydroxide. If we multiply that by the molar mass of ferric hydroxide, we can find number of moles of ferric hydroxide. Okay. Ferric hydroxide mass, we can calculate. Let's see how much came from potassium permanganate. So this is the potassium permanganate moles. So one potassium permanganate has one manganese. So that is the number of moles of Mn2 plus number of moles of MnOH twice. Multiply that by 89, which is the molar mass of manganese hydroxide. So this is the mass of manganese hydroxide. All right. Then ferric hydroxide came from Fe2O3 equals total minus ferric hydroxide came from FeO and manganese hydroxide. So then you are getting the mass of ferric hydroxide, which equals 0.3210. Mass divided by molar mass is the number of moles. So this is the number of moles of ferric hydroxide gotten from ferric oxide. But ferric hydroxide to ferric oxide is 1:2 because you have one ion here, but two ion here. Divide by 2 is the number of moles of ferric oxide. That multiplied by its molar mass to get the mass. That percentage is the ferric oxide percentage, which is the 50%. Last year one is little easier because last year they were saying that only 2 compounds are there. Here this time they are saying inert one is there. Hasintha, I'm thinking of you too, okay? Hasintha is the newest member of our family. Last question. I did a little slowly today because this is your last day. Manufacture of H2SO4 acid by contact process. 3 raw materials are sulfur, sulfur ore or petroleum refinery, air and H2O. Then they are asking the balance equation. Sulfur plus oxygen SO2, SO2 plus O2, 1 atm 450 degrees Celsius, V2O5 catalyst. You have to write everything. 2 SO3 gas, SO3 plus conc H2SO for H2S2O7. That all in plus H2O gives the H2SO4. Last year they were considering the physical state, but this year they were not considering. I don't know. Two strategies used in increase efficiency, using several steps to convert entire amount of SO2 and SO3 via catalytic chambers, using atmospheric air to increase O2 concentration to maintain O2 is to SO2 ratio as 1:1. Two principles used to determine optimum condition. Explain using above reaction. Number 1 is the Lesch-Shelley principle. You have to show this equation. This is negative exothermic. Since exothermic, when temperature decreases, forward reaction favors. But low temperature will decrease rate of reaction. Therefore, an optimum temperature of 450 degrees Celsius is used. Increasing oxygen concentration favors forward reaction. Therefore, actually, a 1:1 ratio of SO2 is to O2 is used, even though stoichiometric ratio is 2:1. Counter current principle. SO3 plus H2SO4 gives this H2S2O7. SO3 gas moves in an upward direction, while H2SO4 trickles downward, enabling the more efficient absorption of SO3 into H2SO4. Industries utilizing these H2SO4 as raw materials, phosphate fertilizer industry, artificial fiber, manufacture detergents containing alkyl and aryl sulfonates, dyes, explosives, medicines, battery acids to dry gases. Gases directly contributing to global warming, non-halogenated carbon compounds and nitrogen compounds. And their oxidation numbers are asking CO2 plus 4, CH4 minus 4, N2O plus 1. Released to atmosphere due to human activities, CO2. A combustion of carbon compounds of fossil fuel and biomass are converted to CO2 gas. Biomass grounded during deforestation is oxidized by aerobic bacteria to CO2 gas, CH4. Improper disposal of waste materials produce CH4 due to the action of anaerobic microorganisms on organic matter. Extensive rearing of remnant animals in animal farming releases CH4 gas due to conversion of organic matter by gut bacteria. CH4 is released to the atmosphere by fossil fuels, retrieval and refinery processes. N2O, soil bacteria action on nitrogen fertilizers produce N2O. How above compounds contribute global warming? All above three compounds are greenhouse gases. These greenhouse gases absorb infrared radiation that are re-radiated from planet's surface. The IR absorption retains thermal energy for a long time and heats up the planet and maintains the temperature. Elevation of the composition of these gases due to human activities occur. Retention of more IR radiation energy and elevates the global temperature. See, we have wanted to do this question number 14. If you are doing this, you have to first explain what is this greenhouse. Then you are explaining why this is harmful, these gases. Greenhouse effect. Two nitrogen compounds directly contribute to photochemical smoke. NO and NO2 oxidation numbers are +2 and +4. Formation of troposphere ozone by a nitrogen compound is asking. NO2 goes for NO and oxygen. That atomic oxygen with O2, it is making O3. Why the tropospheric O3 level reaches maximum in afternoon? Tropospheric. Solar radiation is an essential factor for photochemical smoke. Intensity of solar radiation is reaching maximum at noon, and therefore photochemical smoke reaches maximum level in the noon. See, last time they were asking why it is low in morning and evening. Noon time it is high, now they're asking that. 3 water quality parameters affected by dissolution of nitrogen and sulfur acids: pH, acidity, electrical conductivity, algae nutrients, and nitrate and phosphates, heavy metals, arsenic, sulfide, cadmium, lead, and mercury, water hardness, calcium, magnesium levels. Chemical products related to plant sources, the next part. Production of ethanol by fermentation of seed toddy. Equations are asking sucrose with water, sucrase or inertase enzyme, glucose and fructose. These names were there on the marking scheme. You have to write them. Glucose with yeast, methanol and carbon dioxide. Why need to remove free fatty acids from plant oils during the production of bio-oil? To obtain biodiesel of high purity, to have high yield of biodiesel. Free fatty acids, RCOOH, reacts with sodium hydroxide to give soap, RCOONA. If soap is formed, foam is formed, which inhibits the catalytic action of sodium hydroxide, so that inhibits trans-esterification reaction. Why essential oil is separated by steam distillation at temperatures lower than boiling point of both? Essential oil and water are immiscible. Gas phase can be considered as a mixture of saturated vapors of water and essential oils. Total pressure equals saturated vapor pressure of water and essential oil, so that The mixture will boil when Pt equals to P external. In the case of pure liquids, P external equals P naught liquid at the boiling point. In the mixture, since both the liquids contribute, total pressure become equal to the P external at a temperature lower than the boiling point of either liquids. I'm not happy with this answer, but this is the answer they were given for. This is not enough for equilibrium. All right. Last day, you guys made me really, really happy. Actually, I'm satisfied. Make your brain really happier. And I want you guys to beat this 29th position. I know you guys can do that now. So stick to the plan. Let's do this everything nicely. I'll talk to you soon. No more classes for you guys. I'm just going to post this, the last talk to the group so you can go through that. Go through that. It's a must. That is the last plan. I'm just giving all these instructions to you. So well done, guys. I'll talk to the next day, okay? Bye. Take care, everybody. Good night.